Okay, this is a set of points x, y, satisfying this condition over here. It says it forms a curve enclosing a region. Well, I got to figure out what that region looks like. And I want to compute the area of that region. All right. So what I would do here is just kind of look to make an image of it. All right. So you get fifth root x squared plus the absolute value of y is equal to 1. Well, first thing I kind of notice about this thing is there's going to be an image over here, but it looks like it's going to be symmetric with respect to the x-axis. And why is that? If you replace y by minus y, there's no change in the problem. All right, and why is that? Let me write that down for you. Replace y by minus y. And there's no change in the problem. What do you get? The fifth root x squared plus the absolute value of y. This is somewhat helpful. All right. The next thing I notice is it's got y-axis symmetry. And why is that? If you replace x by minus x, let me do that for you. You get the same equation. And what's that equation going to be? Let's write that down. The fifth root of x squared plus the absolute value of y is equal to 1. So I get symmetry over here. All right, the next thing I'd look for is, let me get this rid of this business over here. I'd look maybe just a graph, probably a section of it. And once I get a section of it, I'm going to be able to, use symmetry to get the whole graph. All right. So the way I would do that, look at it, and I notice this thing sums up to 1. And it's going to stay in the first quadrant, by the way. And look at this over here. Like a really easy point would be if I chose x to be 0, y, and I'm sitting in the first quadrant 1. I'm going to say it's up here somewhere. Now, by the way, the y can't exceed 1. All right? There's no way that could happen because you're adding something onto it. If it's 0, it's just not going to happen. And then I kind of look at the other end of the spectrum. What happens when x, when the fifth root of x squared becomes 1, and that happens at 1. The y would have to be 0 there. And it's not going to exceed over there either. Now, someone says, I wonder what the connection is between the two. At this point, it's almost incidental. But I am going to put a connection between the two. And the connection I'm going to put over here is something like this over here. All right? And I want to describe this curve over here as a function of y. So I'm going to solve the equation, and I get this over here. The absolute value of y is equal 1 minus the fifth root of x squared. And that's that section of the curve, by the way. But what do I know about this curve? It's symmetric with respect to the x and the y axis. I'll put this in over here. Again, this is a rough picture. It doesn't make it accurate. All I'm going to do is one section of it and multiply by 4. Here's the deal, though. If I'm in the first quadrant, and I want to stay there, the absolute value of y is just y. And you get 1 minus. Well, I'm going to write this a little differently. It's going to be x to the 2/5. And then I'm going to put an integration. But as I do the integration, the limit of integration is going to start from 0 and end at 1. There's going to be 4 of them now. There's 4 sections. All right, they're all the same. That symmetry helps me with that. What do you give here? 1 minus x to the 2/5 dx. This doesn't look like a bad integration to do. You can get 4 x minus x. Add 1 to that. That would give me 7/5. Divide by 7/5, limit by 5/7. Limits of integration here are going to be from 0 to 1. Let's keep moving. You get 4, 1 minus 5/7, and then minus 4. Well, it's just going to be 0 minus 0. That's pretty easy. That's gone. Let's do the arithmetic now. You get 4, a 7 here, common denominator, 7 minus 5. So it's going to be 2, and 2 times 4 is 8. So the answer we get is 8/7. All right? So I want to just claim, certainly this stuff's written down for you, and that's the answer. I'm agreeing with that answer, by the way. I'm the one who wrote the solution down. Certainly I want to agree with my own. But, I did a rough sketch for you. I do recommend that. My rough sketch is that over there. Again, didn't spend much time in that. In fact, the symmetry did help me a great deal. But I do provide a picture that a machine would draw over here. Certainly better than my picture, right? It has more details in it. But the bottom line, it's really the same object, all right? And we're done. Thank you.